In this video, we will discuss two more examples about related rates, right? Okay, let's try to do the first one. The first one here is basically we have two roads, freeway. They have an intersection point. Let me try to sketch what's going on here, right? So this is our two roads. We have two cars, right? So we have a car A here. We have a car B here. And car A here is moving to the west. And the car B here is moving to the north. Okay, right? We know their speed. Car A here, the speed here is 50 mile per hour. Car B here is faster, which is 60 mile per hour, right? And what do we want to know? We want to know the rate of change of the distance between them. When A here is 0.3 mile from the center point, intersection point, and B here is 0.4 mile from the intersection point, right? Our goal here is find the rate of change of the distance between A and B when A here is 0.3 mile from O, and B here is 0.4 mile from O here. Right, so that's basically the problem, right? We have two cars moving moving in two roads. A here is moving to the west, and B here is moving to the north. And their distance for sure is getting, in this case, it's getting smaller, right? It should be negative. So we want to get a rate of change of their distance, the distance between them, right? So let's try to see that. Okay, so let's try to set up some functions, right? Let's call the distance between A and B to be Z. Let's call the distance between A and O here to be X. The distance between O and B here to be Y, right? So we are looking for dz over dt, right? Let's try to write down the meaning of x, y, z here. X is the distance between O and A. Y here is the distance between O and B. And Z here is the distance between A and B, right? So our goal here is find dz over dt when x is 0.3, y is 0.4, right? And we also know that dx over dt, because this is x is getting smaller and smaller, the rate of change should be negative. So this is negative 50, and dy over dt is negative 60, right? Mile per hour, right? Okay, so that's all the information we are given. We are looking for dz over dt, right? So this is mile. You need to build a relation between x, y, z first. And in this problem, it's clear because x, y, z are in a right triangle, right? Which means x squared plus y squared plus z, x plus y squared is z squared, right? So we know that x squared plus y squared is z squared by the Pythagorean theorem, right? Now we are ready to differentiate, right? Differentiate this equation about time t, right? First term here you get 2 times dx over dt, then okay, 2x times dx over dt, right? Apply chain rule because x is a function of time, so 2x times dx over dt plus 2y times dy over dt equal to 2z times dz over dt. Okay, now we are looking for dz over dt when x is 0.3, y 0.4. We know what dx over dt, dy over dt, but we don't know what is z yet, right? Go back to the original equation here, right? We know that when x is 0.3, y is 0.4, then what? Z square will be z square will be 0.3 square plus 0.4 square, and take a square root using some algebra, and z here should be 0.5, right? Okay, that's good. Now we can plug in all informations. So when x is 0.3, y is 0.4, dz over dt is 0.3 times 2 times negative 50 plus 0.4 times 2 times negative 60 over 2z, which is 2 times 0.5. You can simplify the number, right, to get what's the value of this, right? That should be negative because you can see that their distance is getting smaller and smaller, right? So that's how do we solve this problem here? How do we do that? Okay, now let's see one more example. Okay, I'll see our second example. In the second example, we are given a water tank, the shape of inverted circular cone, right? So this is what's going on here. So we have a water tank. Right? And so this is the water tank. If this is a water tank, we can, okay, we are given some dimensions, and radius of the circle here is 2 meters, and the height here, go from here to here, is 4 meters. And we put in water, we pump in water here in the tank. There are water here inside, right? And the rate of change, the rate we put in is, so water is pumped in, but in the rate which is 2 meters cubed per minute. So that's all we know, right? So what do we want to know? if the water is pumped in, the water level is going higher and higher, right? So we want to find the rate of change of okay, rate of change of the okay, just add which the water is rising when water is 3 meter deep, right? So basically, you want to know how fast is the depth of the water is going up, right? Getting larger and larger, right? So by our strategy, you need to set up an equation between the volume of the water and the height, right? So let's try to do that. So before we do that, let's try to write down equation for that, right? So let me make this. So let's try to do that. So let's see the V here. V here is the volume of water in the tank. And H here is the depth of water in the tank, right? We want to get a relation between V and H, right? But we also need another parameter, which is a radius, right? This is R here. Let's say from here to here is H, right? So we know that V here is 1/3 pi R squared times H by the cone volume formula, right? You know, the base, radius, and height. We are given dV over dt, right? We are not given dr over dt, so we need to somehow cancel r. Look at this equation, this triangle here. We know that r over 2, similar triangles, right? R over 2 is same as h over 4, right? So we get you get what? R is 1/2 h. So we can get a relation between volume and height depth directly. So this is 1/3 pi times h over 2 squared times h, right? So that if you simplify that, volume is basically 1/12 pi times h cubed. Now, what we want to do here is we want to find dh over dt, right? So to differentiate our equation about time t, you get dv over dt is 1/12 pi times 3 times h squared times dh over dt, right? So when height is 3 meter, dh over dt is, we are given dv over dt, right? So dv over dt is 2, so plug in 2 over 1/12 pi times 3 times 3 squared. So that's the this is meter per minute, right? So this is the rate of change of the depth when you have this water is pumped into the tank in the rate of 2 meter cube per minute.